Okay, so hi psychology. Today or this week, we move into chapter 8. Chapter 8 is on complex research designs. Last week, we went over non-experimental research. The week before that, we went over experimental research. There are going to be some, not similarities, but there's going to be some repeat in complex research design. So in this week's lecture, we're going to go over when we would use complex research design, what kinds of projects and questions would benefit from those, as well as why we are going to, or why one would utilize multiple dependent variables and multiple independent variables, okay? So again, we are moving into chapter 8. We are in week 8, so we're going into complex research design. So wasting no time, let's get to it. Okay. So hopefully right now you can see my lecture. And again, one more time, week 8, chapter 8, complex research design. As usual, there are some learning objectives that you are to take away every single week. You can find these on our Blackboard course website, as well as here in our PowerPoint. Again, these are to be used to quiz yourselves, okay? Every single week, there is a quiz with the exception of a few weeks, this week being one of them. However, at the end of completing all of your tasks for this week, please make sure that you come back to these learning objectives and quiz yourself. So for instance, can you explain why researchers often include multiple dependent variables in their studies? Can you explain what a manipulation check is and when it would be included in an experiment? Can you explain some reasons that researchers use complex research design? Or can you create and interpret a correlation matrix? So again, these are just to be used as points to quiz yourself. And again, takeaways from the week. Okay, so let's move on to what we need to move on to. Before I start, I do want to give you guys a slight introduction, as usual, as to what we can expect in the first section of chapter 8. Okay, so here we go. Research in psychology does not only focus on questions about one variable and a statistical relationship between two variables, okay? There are much more complex designs involved. This specific chapter is going to go over why researchers will combine basic elements into more complex ones or more complex designs. In chapter 1 of section 8, Paul Price is going to explain some of the reasons that researchers often include multiple dependent variables in their experiments or studies. He's also going to explain what a manipulation check is in section 1 and when it would be included in an experiment. So going into measures of different constructs. Often a researcher wants to know how an independent variable affects several dependent variables. When one includes multiple dependent variables in the same experiment, there is, again, the possibility of a carryover effect. Remember, Paul Price went over carryover effects in chapter 7 as well as in chapter 6. Again, carryover effects. Please review carryover effects, what they are and when they are likely to occur. Again, you can find them in chapter 6 and chapter 7. One solution, again, to the carryover effect is to measure multiple dependent variables in the same order for all participants. One can also counterbalance the order in which one measures dependent variables, okay? So again, researchers in psychology will often include multiple dependent variables in their experiments. The primary reason for this is that it easily allows them to answer more than one research question, okay? When the independent variable is a construct that can only be manipulated indirectly, an additional measure of that variable is often included as a manipulation check. okay? A manipulation check is when an independent variable is manipulated indirectly. A manipulation check is a separate measure of that independent variable done to confirm that it was successfully manipulated, okay? So again, this manipulation check is done to confirm that the independent variable was in fact successfully manipulated. They are usually done at the very end of a procedure to be sure that the effect of the manipulation lasted throughout the entire procedure and to avoid calling unnecessary attention to the manipulation, okay? One common approach to including multiple independent variables is to operationally define and measure the same construct or closely related ones in different ways. Okay. One common, when you manipulate multiple dependent variables that are different measures of the same construct, one often has the option of combining them into a single measure of that construct. However, it's important to make sure that the individual dependent variables are correlated with one another. If the different measures are not correlated with each other, then it does not make sense to consider them to be measures of the same construct and combine them into a single measure, okay? So again, recall what multiple dependent variables are. Again, more than one dependent variable in the same study. Multiple measures of the same construct can be analyzed separately or combined to produce a single multiple item measure of construct. And the latter approach requires that the measures taken together have good internal consistency, okay? Before we get into the second section, which is on multiple independent variables, so we just went over when we would use multiple dependent variables. Let me just give you guys some takeaways from section 1 of chapter 8, okay? So some takeaways from this first section are that researchers in psychology often include multiple dependent variables in their studies. The primary reason is that it easily allows them to answer more than one research question. When an independent variable is a construct that is manipulated indirectly, it is a good idea to include a manipulation check. This is a procedure that the independent variable typically given, this is a procedure or measure of the independent variable that is typically given at the end of the procedure to confirm that it was successfully manipulated. Multiple measures of the same constructs can be analyzed separately or combined to produce a single multiple item measure of that construct. The latter approach requires that the measures taken together have good internal consistency, okay? The second section of chapter 8 goes on to multiple independent variables. In this section, Paul Price is going to explain why researchers often include multiple independent variables in their experiments. He's going to define a factorial design and the use of factorial design tables to represent and interpret simple factorial design. So he's going to show us how to design these factorial tables to represent and interpret them. We are also going to learn through Paul Pierce's chapter 8 how to distinguish between main effects and interactions and recognize and give examples of each. Also, Paul Price is going to sketch and interpret bar graphs and line graphs showing the results of studies with simple factorial designs, okay? So, just as it is common for studies in psychology to include multiple dependent variables, it's also common for these studies to also include multiple independent variables. Okay. This is shown by the research titles that are examples given in chapter 8, such as the effects of temporal delay or orientation on haptic object recognition, effects of expectancies and coping on pain-induced intentions, etc. So those are just examples specifically of studies that have used multiple independent variables, okay? So using multiple independent variables allows a researcher to answer more research questions, okay? It also allows the researcher to answer questions about whether the effect of one independent variable depends on the level of another, and such interactions are among the most interesting results when it comes to psychological research, okay? The most common approach to including multiple independent variables is in an experiment known as factorial designs, okay? So a factorial design is a research design with multiple independent variables in which each level of one independent variable is combined with each level of the other to produce all possible conditions, okay? So here with the factorial design, each level of one independent variable, which is also known as a factor, okay, is combined with each level of the others to produce all combinations. Each combination then becomes a condition in the experiment. This is specifically shown to us in figure 8.2 in our textbook. Figure 8.2 is on the slide that follows. You can also find this figure on page 141 in your textbook, okay? So here in your textbook, and I'm reading directly from the textbook, imagine, for example, an experiment on the effect of cell phone use. This is depicted here. So the effect of cell phone use, yes, I use a cell phone. No, I don't use a cell phone. And the time of day. I use it in the nighttime, or I don't use it in the nighttime. I use it in the daytime, or I don't use it in the daytime on driving performance, okay? The columns of the table represent cell phone use, and the rows represent the day, the time of day. The 4 cells of the table represent the 4 possible conditions or combinations. So, using a cell phone during the day, not using a cell phone during the day, using a cell phone at night, and not using a cell phone at night, okay? This in particular is a 2x2 factorial design because it combines 2 variables, each of which has 2 levels, okay? So pause here, take a moment to really reflect on this figure and to make sure that you guys understand this figure. Okay, let's go slightly back. Okay. In principle, factorial designs can include any number of independent variables with any number of levels. In practice, it is unusual for there to be more than 3 independent variables with more than 2 or 3 levels each because the number of conditions can quickly become unmanageable. Okay. We also have figure 8.3. This figure you can specifically find on page 142 in your textbook, okay? Figure 8.3. So again, you can find this on page 142 in your textbook. Here, imagine an experiment that could include the type of psychotherapy, cognitive or behavioral, the length of psychotherapy, 2 weeks versus 2 months, and the sex of the psychotherapist, male versus female. This would be a 2x2x2 factorial design, okay? And would have 8 conditions, not 4, but 8 conditions. Okay, so figure 8.3 shows one way to represent this design. Okay. In a simple between subjects design, each participant is tested in only one condition. In a simple within subject design, each participant is tested in all conditions. Okay. In a factorial experiment, the decision to take between subjects or within subjects approach must be made separately for each independent variable, okay? So in a between subjects factorial design, all of the independent variables are manipulated between subjects so that each participant is tested in only one condition. So an example of a between subjects factorial design is that like using the example from page 141, is that all participants could be tested either while using a cell phone or while not using a cell phone, and either during the day or during the night. Okay, this would mean that each participant was tested in only one condition. It is conceptually simpler. It avoids carryover effects, and it minimizes the time and effort of each participant. In a within subjects factorial design, all of the independent variables are manipulated within subjects so that each participant is tested in all conditions. So not one condition, but all conditions, okay? So here, all participants could be tested both while using a cell phone and while not using a cell phone, and both during the day and during the night. This would mean that each participant was tested in all conditions. It is more efficient for the researcher and controls extraneous participant variables. Okay. Continuing on, okay, we also have mixed factorial designs. In a mixed factorial design, one independent variable is manipulated between subjects and the other within subjects, okay? So an example of this would be a researcher might choose to treat all cell phone use as a within subjects factor by testing the same participants both while using a cell phone and again while not using a cell phone. But he or she might choose to treat the time of day as a between subjects factor by testing each participant either during the day or during the night, okay? Regardless of whether the design is between subjects, within subjects, or mixed, the actual assignment of participants into conditions or orders of conditions is done randomly. Okay. In many factorial designs, one of the independent variables is a non-manipulated independent variable. Here, the researcher measures it but does not manipulate it. So such studies are usually participant variables, and as such, they are by definition between subject factors, okay? So for those of you, if that might not be clear, when I say such studies are usually participant variables, I'm really talking about variables such as private body consciousness or self-esteem and so on. Okay. These generally are considered to be experiments as long as at least one of the independent variables is manipulated, regardless of how many non-manipulated independent variables are included. It is also important to remember that casual conclusions can only be drawn about the manipulated independent variable, and therefore it's important to distinguish between variables in a study that are manipulated and those that are not. Okay. The results of factorial experiments with two independent variables can be graphed by representing one independent variable on the x-axis and representing the other using different kinds of bars or lines. The y-axis is always reserved for the dependent variables at all times. In factorial designs, there are two kinds of results that are of interest: main effects and interaction effects, which are also called interactions. Okay. A main effect, just a little vocab here, a main effect is the statistical relationship between one independent variable and a dependent variable averaging across the levels of all the other independent variables. So here we have figure 8.4. You can actually find this figure on page 144. So again, this figure is located on page 144. So this is actually showing the results for a hypothetical factorial experiment. The top panel shows the results of a 2x2 factorial design. So the time of day, which is listed on the x-axis, which is represented by locations on the x-axis, and also cell phone use. So whether or not one utilizes a cell phone, yes or no, is represented by the different colors. Remember, the dependent variable is always set on the y-axis. So this one, x-axis, y-axis. Okay, so it would be possible to represent cell phone use on the x-axis and time of day as different colors as well. Okay, the bottom figure of 8.4 shows the results of a 4x2 factorial design in which one of the variables is quantitative. This variable, psychotherapy length, is represented along the x-axis, and the other variable, psychotherapy type, is represented by the different formatted lines. This is a line graph rather than a bar graph because the variable on the x-axis is quantitative with a small number of distinct levels. Okay. So again, this is figure 8.4, and you can find this specific figure on page 144. Okay. So again, just a little review. A main effect is the statistical relationship between one independent variable and a dependent variable averaging across the levels of the other independent variables. And we just referred to figure 8.4 as an example. There is an interaction effect when the effect of one independent variable depends on the level of another, okay? So an interaction effect in a factorial design is when the effect of one independent variable depends on the level of another independent variable. Okay, an example of this is the effect of receiving psychotherapy is stronger among people who are highly motivated to change than among people who are not motivated to change. Thus, the effect of one independent variable, whether or not one receives psychotherapy, depends on the level of another, so the motivation to change. The effect of one independent variable can depend on the level of another in different ways. So for this, let's refer to figure 8.5. Okay, 8.5, you can actually find this figure on page 146. So in the top panel, one independent variable has the effect at one level of the second independent variable, but not at the other. In the middle panel, one independent variable has a stronger effect at one level of the second independent variable than at the other. And in the bottom panel, the last one independent variable has the opposite effect at one level of the second independent variable than at the other. Okay? So again, the effect of one independent variable can depend on the level of the other in different ways. And we are referring to figure 8.5 to illustrate this, okay? The strongest form of this kind of interaction is the crossover interaction, which is also illustrated in this figure. And a crossover interaction, just scrolling back, is an interaction in which one independent variable has opposite effects at different levels of another independent variable. Okay. In many studies, the primary research question is about the interaction effect. Okay. We also have figure 8.6, which I just threw in here as extra, but as we saw in the previous figures, we always can do the factorial design with the bar graph, or it can include lines. Okay, so here's one that you can find on page 147 for the interaction effect, not the factorial design, but an interaction effect. In the top panel, one independent variable has the effect at one level of the second independent variable, but not at the other. In the middle panel, one independent variable has a stronger effect at one level of the second independent variable than at the other. And in the bottom panel, one independent variable has the opposite effect at one level of the second independent variable than at the other. Okay? And again, in many studies, the primary research question is about the interaction effect. And your book does give you an example of the study by Brown and her colleagues, which was inspired by the idea that people with hypochondriasis, sorry, I don't know how to really pronounce it, are especially attentive to any negative health-related information. So you can look at that as an example as well with this figure, okay? So some takeaway points from this specific section in our textbook, okay? Researchers often include multiple independent variables in their experiments. The most common approach is the factorial design, in which each level of one independent variable is combined with each level of the other to create all possible conditions. Another takeaway is that in a factorial design, the main effect of an independent variable is its overall effect averaged across all other independent variables. There is one main effect for each independent variable. The last takeaway from section 2 is that there is an interaction between two independent variables when the effect of one depends on the level of another. Some of the most interesting research questions, specifically, result in psychology are specifically about interaction effects, okay? Our last section, section 3, goes into complex correlational designs, okay? In this section, Paul Price is going to explain some reasons that researchers use complex correlational designs. He's also going to show us how to create and interpret a correlation matrix. And lastly, he's going to describe how researchers can use correlational research to explore causal relationships among variables. In this, he includes the limits of this particular approach as well, okay? Factorial designs can also include only non-manipulated independent variables, in which case they are no longer experiments, but correlational studies, okay? One must be cautious about inferring causality from correlational studies because of the directionality and third variable problems. We also refer to this as spuriousness, okay? Most complex correlational research, however, does not fit neatly into a factorial design. Instead, it involves measuring several variables and then assessing the statistical relationship amongst them. An example would be researchers studied a sample of middle-aged adults to see how their level of optimism relates to several other variables related to having a heart attack, okay? They found that the more optimistic patients were healthier, knew about heart attack risks, and correctly believed about their own risk to be lower than that of their peers. This approach is often used to assess the validity of new psychological measures, okay? Just a couple, not a couple, but just some vocab that sticks out in this section. One is a correlational matrix, right? A correlational matrix shows a correlation between every possible pair of variables in a study. For this one, I want us to refer to figure 8.1, table 8.1, not figure 8.1. But this is a correlational matrix showing correlations amongst the need for cognition and 3 other variables based on research by CACIOPPO and Petty. You can find this specific table on page 149 in your textbook. So CACIOPPO and Petty created their need for a cognition scale, a measure of the extent to which people like to think and value thinking. They used it to measure the need for cognition for a small sample of college students, along with 3 other variables: intelligence, social desirability, and dogmatism. Okay. The results of this study are summarized obviously in table 8.1, which is a correlation matrix showing the correlation between every possible pair of variables in the study. Okay, so pause and just make sure you can see how this specific table shows the correlation between every single possible pair of variables in the study. So Pearson R. Okay, let's pause at that. Okay. When researchers study relationships among a large number of conceptually similar variables, they often use a complex statistical technique called a factor analysis. This organizes the variables into a smaller number of clusters such that they are strongly correlated within each cluster, but weakly correlated between the clusters. Each cluster is then interpreted as consisting of multiple measures of the same underlying construct. These underlying constructs are also called factors. Factors are not categories, but operate independently of each other. Factor analysis only reveals the underlying structure of the variables. An important use of complex correlational research is to explore possible causal relationships amongst variables. Okay? It is true that correlational research cannot unambiguously establish that one variable causes another. However, complex correlational research can often be used to rule out other plausible interpretations. The primary way of doing this is through statistical control of potential third variables by measuring them and including them in statistical analysis. Such kind of analysis such kind of studies use statistical techniques called multiple regression, okay? Multiple regression is a statistical technique that describes the relationship between multiple independent variables and a single dependent variable in terms of an equation that shows the separate contribution of each independent variable to the dependent variable, okay? This regression equation has the following general form. And I will actually list, you can actually find that form, not that I will list it, but you can actually find that form on page 151. I don't know if you guys can see it, but it's right there, okay? The quantities B1, so if you, I wouldn't say pause, but if you open your book, right? So the combinations B1 and B2 and so on are regression weights that indicate how large a contribution an independent variable makes on average to the dependent variable, okay? The advantage of, multiple regression is that it can show whether an independent variable makes a contribution to a dependent variable over and above the contributions made by the other independent variables, okay? So lastly, what I want to say is that it's important to keep in mind, however, that purely correlational approaches cannot unambiguously establish that one variable causes another. The best it can do is show patterns of relationships that are consistent with some causal interpretations and inconsistent with others. So just 2 takeaways from section 3 of chapter 8 is that researchers often use complex correlational research to explore relationships among several variables in the same study. Complex correlational research can be used to explore possible causal relationships among variables using techniques like multiple regression. Such designs can show patterns of relationships that are consistent with some causal interpretations and inconsistent with others, but they cannot unambiguously establish that one variable actually causes another. So that is section chapter 8 for you guys on complex designs. I do want to state that you guys will, if any of you are interested in statistics, specifically quantitative research methods, one of the most common approaches that you will probably use is multiple regression. And it might look complicated, but with the programs that we have, statistical analysis software that we have, it makes it so much easier. And on top of that, it's not that difficult, okay? So that is complex research design for you guys, and I will see you guys in the next lecture. Bye.